All right. So, question? Go ahead. Yes, go for it. So, as to reiterate, once again, a bunch of practice quizzes, and then on Thursday will be a quadratic formula real quiz. It will be very similar to what you've done today. A very short number of questions, probably one page single-sided, just to make sure you're keeping up with the homework, since it is mathematically heavy. Today, we're going to take a look at the quadratic formula again and talk about when do we use it, and see if you can catch that in word problems. So going to our sheet from the other day, this is basically your textbook. Any questions from number 3? I remember for homework, I said, don't worry about the word questions. Tell me if you can do these, like just the mechanics of it all with straightforward math questions, right? So that's your K-style question right there from a quiz or a test. Any questions with that? Okay. So if you know how to do it, we're going to take a look at why/when we do it. As a reminder, I'm going to ask for your input here. Let's pretend I have an equation like that. And let's pretend it was like, I don't know, like f of x. You don't have to write this down, is equal to x squared plus positive 4x minus 12. That's it. How do we calculate the x-intercept? Forget chapter 4. Like, let's go back to chapter 2 and 3. How did you normally calculate the x-intercepts? Once. Going twice. Really? Are people just being tired, or do they actually don't know? Be honest, no judgment. You forgot. Forgot. Okay, it's time for people. Other people are just going to be tired. Up until now, if you wanted to find the x-intercepts, you had to factor. You remember that? Like you would get x minus 6 and then x plus 2, which means that's a plus 6 and that's a minus 2, something like that. There, start slowly ringing a bell. Yeah. Okay. So the point of the quadratic formula is, let's say you have another equation, and it was not quite 2, and it was not quite 6. Right? What if the equation was something like f of x is equal to x squared plus 4x minus 11? There are no numbers that will multiply to negative 11, but add to a 4. In other words, I can't factor. If I cannot factor it, I can't figure these 2 points out. And if I can't figure these 2 points out, well, I can't solve the question. Dun, dun, dun. Quadratic formula will help you find these numbers even if it's not factorable. So in other words, not factorable, that's okay. Or rather, no problem. No problem at all. You can still find those x-intercepts. So take a look. Here's an equation. We're going to do number 6 together, but just focus on the equation. Can you factor that? Find 2 numbers that multiply to 1.85 but add to 20. Think you can do that? That's annoying. This is where quadratic formula comes in. I hope you see its usefulness very soon. We're going to do number 6 together. Maybe we'll also do number 7 together. And the rest of those questions you can try on your own. The answers, of course, are already there for you. And that's the end of today. And tomorrow, just doing the quadratic formula, the quiz will be on this formula. Okay, here we go. On Mars, if you hit a baseball, the height of the ball at time t would be modeled by the quadratic function h of t equals negative 1.85t squared plus 20t plus 1. T is in seconds. I have to remember this. And the y value, h of t, is in meters. When will the ball hit the ground? So in this simple sentence, there's a lot going on. When? English word. What are they asking for? Mathematically. Yeah? You don't know that yet. Just the word when. What does that mean in terms of this equation? Yes. Right. Time, which is what refers to the word when, right? When refers to time, and that's in seconds. Time is the number that you would plug in. In other words, time is representing the x values. So mathematically, question A is asking, what is x when what? What partners with the x? Well, y. If they want to find out what x is, they have to give you the y. And that's what the second point is. It hit the ground. That means height is a 0. It hits the ground. Height being 0, height represents the y value. And therefore, they're asking, what is x when y is 0? What is time when height is a 0? And that's another way of saying, what is the x-intercept? It's the same thing, which is what you're saying, right? That's exactly what it is. But sometimes it's not going to be time. Sometimes it's not going to be height. What if it's like production of skateboards and how much money you make, right? What if it's how far you jump this way, and as a diver, how far you drop into the water, right? There could be a whole bunch of different things that x and y could be. Right now, it's easy to understand because it's time. But if it's not time, suddenly things might get a little bit wonky. So it's important for you to recognize what your x value is and what your y value is. Okay, so here it is. What is time when height is 0? I am going to plug in my height of 0 into the equation. And what does that give me? Well, something that's non-factorable. Wouldn't it be nice if we had two brackets, right? Like time minus 1 and time plus 1. I don't know, something random like that. Then you know time has to be plus 1 or time has to be negative 1. Like that's what we normally do. But again, we can't factor. So what do we do now? So I'll say the little star cannot factor. If you ever get to a point where you cannot factor, quadratic formula. Fun fact or helpful hint, even if you could factor, if you don't like factoring, you can use quadratic formula. They are one and the same. Quadratic formula essentially does the factoring for you per se, sort of, and finds you what the roots are. Okay, so let's do it. My a value, and this is where people who are away on Friday come in. My a value is a coefficient multiplying with the squared term. My b value is the coefficient multiplying with the single exponent, one exponent term. And my c value is the constant term. If you want to know what t value makes this equation a 0, it has to be a 0. Then you plug it in. Negative b plus minus square root of b squared minus 4ac divided by 2a. And I'll plug in the numbers for you, but since I'm limited in space, I'm going to ask you to help me calculate it. So this would be negative positive 20 plus minus 20 squared positive 20 squared, minus 4 times A, which is also a negative, times C, which is a 1, all over 2 times negative 1.85. I'm going to see if I can get some more white space for myself. All right, there we go. There's maybe space for this. If I go further, I'm gonna have someone calculate the square root portion for me. I have no idea what's underneath that, but I know that down here it's negative 3.7. Someone solve that for me. Maybe a couple of people can do it together so that we can confirm each other's answers. Actually, solve it and then do the square root so that we don't have to. What do you get here? I got 20 point, I'm going to round it, 1/8. Just double check for me. I'm going to wait until someone confirms. Yep. Yeah, just someone double check the part portion in underneath the square root. 1841. Good. Anyone else? We got 2 people here. Okay. So I'm going to do, so if you have the square root portion as 20.18, so I solve that part. I have, and in case you're wondering, you still don't quite see what I'm doing. Oh, this portion right here, right, with the square root and all, I put it into the calculator, and if you did it right, it should have become 20.18. By that, I mean t could be negative 20 plus this blue number, or negative 20 minus that blue number. You have to consider both. And if both make sense, great. If only one makes sense, great. Math doesn't lie that way. And so let's do it. Someone's going to have to do the top number. Someone's going to have to do the bottom number. I will do the bottom number, I guess. 1, 20. This gives me approximately 10.86 seconds, or 10.86, which I'm interpreting it as seconds because that represents t. What about the other one, Cameron?
How did you get
The blue part. I plugged in the calculator 20 squared, and then I'm subtracting with a 4 times negative 1.85 times 1. So in doing this part, I got square root of about 407 point something. You do that in the calculator. If you do square root of that, you should get 20.184, 18 something. Yep. This one? Oh, you know what? You have to put this in brackets. The numerator must occur before that division. So it's like you have to break BEDMAS if you like. Computer will do BEDMAS flawlessly. Mm-hmm. Good. 0.09. So T, remember, represents seconds. So it's going to be, so when ball is on the ground, T equals, don't write this yet, 0.09 or 10.86. Logically speaking, if this is correct, when is it that the ball is landing on the ground? Does it make sense here? Does the story make sense? Which of those two represents the ball landing? Think about it logically. Somebody else. People have been keeping up. Just be brave about it. Hayden, are you with me? So I have 2 times, and they're both on the ground. What do you think the answer to my question is? Why? Why does this not make sense? Or what is it more likely to be? Absolutely. Remember, the context is that we're hitting a baseball or something on the moon, on Mars, right? Which obviously doesn't make any sense. But anyways, assuming that this is a parabola, and also notice that the A value is a negative, most likely something like this, right? Where, you throw the ball in the air and you hit it. So it's not quite at 0, right? Or at 0.1 second, it gets hit and it goes all the way up and lands back after a full 1.86 seconds. So, or sorry, 10.86 seconds, which is a long flight, but it makes sense because you're on Mars and gravity sucks there. And so that's it. Would you be able to factor this? If you did factor it, it would look something like T minus 0.09 and T minus 10.86. There's no way we're going to guess these numbers by factoring. That's where quadratic formula comes in. That's it. So long story short, I wish I could write this, but I don't have enough space. The point is this. If ever you need the X-intercept, or if ever you need a situation where you're looking for the X values, you can use quadratic formula. End of story. I see some people copying and stuff, that's fine. I'm going to pause the video and ask people to attempt number 1B. Go back to the question. It says, how long will the ball be above 17 meters? So again, what are they looking for? And what do they give you in terms of X and Y? I'll leave this question up here and we will finish off today's lesson with that. So take about 5 minutes, see if you can at least identify what the question is asking for and see if you can create a mathematical equation based on what the question is asking for. Okay, I don't need you to calculate all this right now because that's what our quiz is for, right? See if you can at least get an equation so that we can get started. I'll give you 5 minutes. All right, so I don't know how many people attempted it, but this is what you might have started with. Remember, h of t, based on this equation, or based on this question, is this. Oops, is that a minus 20? Is it a minus 20 or a plus 20? Anyone? Yeah, at least show me that you've tried it, even if you don't quite get it. Plus 20. Please keep up. I need some feedback from you to know that at least the lesson is being followed. Here we go. it says, how long is it above 17 meters? Okay. So this is interesting. This time they're asking, how long, in other words, time, is it going to be at least 17 meters? So that seems a little hard to do, but what you can do is first figure out at what time is the height going to equal 17, and we could interpret it from there. Consider this. If we have that same parabola, and if we can figure out what this number is, and if we can figure out what that number is, the amount of time between those two is what we're looking for. Let's solve it out. Height. They actually give you, essentially, they're asking you, when is the height going to be 17? And they want to know what time is. Well, okay. Since they are asking for the x values, we could use quadratic formula, except we have one issue. The y value, the left side of the equal sign is not 0. Look at the difference between A and B. When will the ball hit the ground? In other words, when is the height 0? How long will the ball be above? When the height is 17. If you want to use quadratic formula, put a little star there as a note, saying the side must be a 0 if you want to use quadratic formula. Must be 0 every single time. So I'm going to rearrange it. Subtract both sides by 17, leaving one side as a 0, and the other side will have a change equation. It's not a +1 anymore. It's 1 minus 17. It's a minus 16. Now we can do quadratic formula. My A value is negative 1.85. My B value is a 20. And look how this is different than part A. Your C value is a negative 16, not a +1. So it's slightly different. But remember, in part 1, this was 0.09, and that was 1. What was it again? Oh, sorry, 10.86, right. And it goes up and comes back down. Assuming that this is 17 meters, I will get a number that's bigger than 0.09, but definitely smaller than 10.86 because it has to still be in the air before 11 seconds. It has to be still in the air before that 0.09 seconds. So let's try it. If I want my my height to be 17, I'm going to set it to a 0 and figure out what that time is going to be using negative b plus minus b squared minus 4 times a times c. All divided by 2 times a. I will leave this for you to calculate. I'm going to do it privately, but I know that my t value should equal 2 possibilities. Let's figure this out. Square root of 20 minus 4 times a times c. So this is going to be negative 20 plus minus 281.6 over, okay. T is going to be negative 20, just a plus or minus. It's going to be either a plus or a minus Hey, very good. Some of you are just waiting for me, so I'll go ahead and do it. The first number was right on track. I got approximately 0.87 seconds. Is that after my launch? Yes. It's almost 1 second. This is definitely after my launch. Okay. It hits 17 meters almost 1 second after the launch. Great. So this should be just a little bit before my landing. If you calculate this, I got approximately 9.94 seconds, which is correct. It's smaller than 10.86. So I think we're on the right track. The question says, how long is it above? So tell me, how long is it above? How would you do that? If I hit 17 at 0.86, if I get under 17 at 9.94, then the amount of time in between is number of time in between 9.94 minus 0.87. 9.07 seconds. So the ball will be up here for a little over 9 seconds before falling back down. As you can see, there is more thinking involved. It's not just plugging into the equation. The quadratic formula doesn't give you 2 specific points, but you could do a lot with it. You can say, hey, what's the amount of space between it? What's the amount of time between it? Or I can say, what's the amount of time under it, right? There's a lot of different things that I can ask for. So as opposed to just memorizing how to do things, it's really important that you are able to understand when, why we do these, so you can address the question. Mathematically, getting to this point right here is all you need to do. But if you are using it in a word question, this was an extra step that was required because that's what they're asking for. And this is not something I'm teaching you, but it's something I sort of expect you to know because, hey, if you had 10 meters and then you traveled 1 meter, how much is left? You would know how to subtract, just small things like that. That's it. I will stop the video here, but again, just to get you used to these kinds of questions and in preparation for another quiz on Thursday, I'd like you to try the other 3 questions we have not done yet in this sheet. Remember, tomorrow we are going to move on, but is everyone okay with this? I'm going to clear this. Actually, maybe not. Let me just go back to my whiteboard. So we talked about when we use it and we look at word problems. I'm going to clear this and write down your homework. Please practice word problems. Those are questions, what, 7, 8, 9, and even 10, right? So that's numbers 7, 8, 9 to 10 in handout. And number 2, practice quiz. That'll be again, it'll be 20 minutes tomorrow in class. Right? Remember, there's also Wednesday practice quiz. And then Thursday, it's the real quiz. Thursday is also a shortened day. Friday is also a shortened day. Any questions? Yep.
On the practice tests.
No.
Is this one your
This one is the real one. It's counts for marks. Yes.
And Thursday is at the village, pass.
Correct, just like today. It's gonna be one page, single-sided, see what you can do based on what we've done before. Good for you. Okay. Yes.
Sorry. Sorry. I know you already explained this, but